Hello, everybody. My name is Paul Beckwith, and in this video I'd like to chat about new work by James Hansen on basically he puts together his arguments from previous papers showing that the climate sensitivity, so the amount of change in temperature for a given doubling of CO2, of greenhouse gases, is not 3 degrees Celsius, which is what the climate modelers, the Intergovernmental Panel on Climate Change, and many people in climate science are claiming. Hansen is showing with over 99% certainty that the climate sensitivity is not 3 degrees Celsius, it's 4.5 degrees Celsius. Like I said, 99% certainty. You can't just rely everything on models that you tweak to give you that 3 number. You have to take into account 3 different sources of information. Number 1 is the paleoclimate, what's happened in the past, how much temperature has changed between glacier and interglacial warm periods, right? How much it's changed. And it gives you a handle on climate sensitivity, because we know the greenhouse gas changed between those times, and that incorporates all the feedbacks. Modern day observations, especially the spike in temperatures in the last few years. So that's number 2. And the third method is the global climate models, which is used almost exclusively by the IPCC to come up with their numbers. So the key factor is the Intergovernmental Panel on Climate Change has both the climate sensitivity wrong and the aerosol contribution to climate warming, or the amount of sunlight blocked when the aerosols are in high quantities in the atmosphere. They have that number completely wrong too, and those two things cancel out, and they can tweak the climate models to basically explain it off, but they cannot explain what's happened in the last couple of years. They can't. So the picture is becoming clearer and clearer. Hansen has written extensively on this. So his latest post on his Columbia website shows that very clearly, and that's the paper I'm going to discuss right here. It's called Seeing the Forest for the Trees, and it came up on the website, Hansen's website, August 6, 2025, which was just yesterday. If you just Google James Hansen Columbia and click on his link, then it brings you to his recent communications, Seeing the Forest from the Trees, okay, just posted yesterday. Okay, so it's very, very important paper. So let's have a look at what it says. So climate sensitivity is substantially higher than the Intergovernmental Panel on Climate Change's best estimate, which is 3 degrees Celsius for doubled CO2. It's much higher than this number, and they conclude that with greater than 99% confidence. They also show that global climate forcing by aerosols became stronger or increasingly negative during 1970 to 2005, unlike IPCC's best estimate of aerosol forcing. So the IPCC gets 2 things wrong. They get the climate sensitivity wrong, and they tweak the aerosols to give the numbers to try to explain observations with a lower climate sensitivity. So the high confidence in these conclusions that Hansen is making and his people are based on a broad analysis. The IPCC underestimates both climate sensitivity and aerosol cooling. They tweak it with the models. They almost exclusively use the climate models, and they ignore the paleoclimate and the modern observations. And they throw up their hands and say, wow, we didn't expect it to warm so much the last few years. So this is probably the most important stuff in climate change that I'm bringing to you here, thanks to James Hansen and his colleague. They did 2 recent papers. One was Global Warming in the Pipeline. And if you haven't seen these papers, it's worth having a look. And the second one, Global Warming Has Accelerated. Okay, very long papers, very thorough, and they raise numerous issues. So the most important conclusions are here. One of the principal objectives of research in climate change is to evaluate the climate sensitivity. How much does the temperature rise globally with a doubling of CO2 when you incorporate all of the feedbacks? Okay, so the problem, you can't just rely on the global climate models, the GCMs, which the IPCC continues to do. They don't want to admit that they're wrong, and the planet is suffering as a result. Humanity is suffering. Hansen and his group have equal emphasis on three sources of information. Number one is paleoclimate data, the long history of climate change. Number two is modern observations of ongoing climate change, what's happened specifically in the last couple of years or last decade. And the third one is the GCMs, the global climate models. They use all three tools, and they conclude with a high degree of confidence because all three tools show the same thing, which differs from what the IPCC concludes. So Hansen talks about Jules Charny, who understood that the most basic climate issue is climate sensitivity. So let's have a quick look at who Jules Charny is. He's an American meteorologist. He played an important role in developing numerical weather prediction and increasing understanding of the general circulation of the atmosphere. Because this was the time of the introduction of the first digital computers. They had increasingly sophisticated math models of the atmosphere, and his work was behind many national and international weather initiatives. So he's considered the father of modern dynamical meteorology. He guided the post-war evolution of modern meteorology more than any other living figure. He had close colleagues, famous Edward Lorenz, who looked at the limits of predictability and was a pioneer of the field of chaos theory, which applies to a lot of weather stuff. Okay, so Charny was very important, and he started a lot of, he was at the Institute of Advanced Study in Princeton, he was at MIT, his work paved the way for founding of NOAA's Geophysical Fluid Dynamics Laboratory, National Academy of Science, and so on. So he was, fundamental in the initial weather models and so on. Okay, so he understood that the most basic climate issue is climate sensitivity. How does the climate respond? How high does the temperature go to a standard forcing? A forcing mostly being doubling of greenhouse gases, doubling of CO2 in the atmosphere. So when U.S. President Carter's science advisor requested a report on climate implications of fossil fuel use, Charny focused on a study by the U.S. National Academy of Sciences on a specific question: what is the equilibrium or eventual global temperature response to a doubling of atmospheric CO2? Doubled CO2 causes a climate forcing of about 4 watts per square meter because CO2 absorbs the shortwave radiation, the long-wave radiation, the infrared radiation coming from heating. It absorbs the heat. It reduces, so it traps heat in the Earth system, reduces Earth heat radiation to space, the long-wave radiation up to space. Shortwave radiation is the sunlight coming in. They relied on early global climate models, and the Charny report concluded that climate sensitivity was likely in the range 3 plus or minus 1.5 Celsius for doubled CO2. They only had 50% confidence in that number. So you need to look at the forcings of climate change. Okay, so in the first Hansen paper, they showed that it's basically you're looking at two forcings, the greenhouse gas forcings and the aerosol forcings. There's several human-made and natural climate forcings, but they're smaller and partially offsetting. So we can measure greenhouse gas amounts accurately, and their greenhouse gas forcing agrees with that of the IPCC within about 1%. Okay, the aerosol forcing is more difficult to measure because it occurs via, there's two effects: a direct effect of what the aerosols do themselves, and the indirect effect, because they act as cloud condensation nuclei, so the effect on clouds, that's the indirect effect. So there's not a lot of adequate aerosol cloud measurement, so there's large uncertainty in the aerosol forcing, mostly in the clouds. So it's looked at indirectly. So what are some of the methods? Well, you look at paleoclimate. To get a reliable assessment of climate sensitivity, you look at the global temperature difference between two stable climate states. So they look at the Last Glacial Maximum, for example, and the present Interglacial. If the global temperature change and the climate forcing change between the two states are known, then you can get the sensitivity. And that, of course, includes all climate feedbacks, because it's what the system is telling you. This is not the case with climate models. So we know the paleoclimate period going back several 100,000 years from ice cores, air bubbles trapped in ice cores in Greenland, but most going back further in Antarctica. The big uncertainty is using the glacial, interglacial climate change or temperature change to evaluate climate sensitivity. Okay, so there's different ways that have done this. CliMap was a large National Science Foundation project, looked at climate conditions during the last glacial maximum. It peaked, Hansen says, about 20,000 years ago. I always think of 21,000 years ago. Sea surface temperatures are the most crucial data because the ocean covers 70% of the planet. And global sea surface temperature tightly fixes global surface temperature. So, the sea surface temperatures estimated by the CliMap project showed that global temperature during the last glacial maximum was about 3.6 colder. This would mean a climate sensitivity was 2.4 for doubled CO2. Okay, and that was discussed at a conference in 1982. But how did they get their sea surface temperatures? They mostly got it by looking at the geographical distribution of tiny species living in the ocean, at the ocean surface, and the temperature ranges that those species undergo. But they found that's since been proven not very accurate. Pollen data shows cooling at low latitudes was twice as large as the CliMap sea surface temperatures. Last glacial maximum snow lines on low latitude mountains descended twice as far as the CliMap sea surface temperatures. So the sensitivity was larger as a result of this additional data, between 2.5 and 5 Celsius for doubled CO2. Okay, but this net evidence, this paleoclimate evidence for high climate sensitivity is neglected by IPCC for decades because of the uncertainty in the paleoglobal temperature change. Okay, so we know now that CliMap underestimated the Ice Age cooling. There's different chemical proxies. Some numbers came up to be a cooling of 6.1 Celsius for the period 23 to 19,000 years ago, 7 Celsius for maximum cooling, 21,000 to 18,000 years ago. Groundwater deposited, cooling of 5.8 on land between 45 and 35 north. So paleoclimate data yielded a doubled CO2 equilibrium climate sensitivity of 4.8 Celsius plus or minus 1.2, 95% confidence. The IPCC best estimate is 3 degrees Celsius, so that can be excluded with greater than 99% confidence, according to Hansen. So here's the Earth albedo. This is a kicker. Since 2000 to present, the Earth albedo is the reflectance of the Earth to the sunlight, to the shortwave solar radiation. Looks like 29.4 Celsius here, and it's down to about 28.7. Okay, so this is the albedo change, minus 0.5, and it was slightly above. So it's been large. The Earth is darkening as seen from space. This is a BFD. BFD stands for what you think it stands for. Hansen's he doesn't mince words. It's a BFD because an albedo reduction of 0.5% is a global average increase of absorbed solar radiation of 1.7 watts per square meter. And that's, if you do a linear fit, it's more like a decrease of 0.58%, almost 0.6, which is almost 2 watts per square meter increase of absorbed solar radiation. Because the Earth is darker, it's absorbing more solar radiation. This increase of absorbed energy is about half of the climate forcing caused by doubled CO2. It's sure to cause global warming, but we also need to know other feedback. So as the surface becomes darker, as the area covered by ice decreases, snow cover decreases, and also clouds. There's fewer low-level clouds, so more of the Earth is exposed. It's darker. Clouds are basically white and reflective. So we're getting an amplifying cloud feedback. And most of the increase of absorbed solar energy, the dropping of the reflectivity of the Earth, the darkening, must be due to cloud feedback because the other contributions are small. So surface darkening is mainly due to reduced sea ice cover, also snow cover in the spring. You can identify this by satellite measurements of Earth's radiation balance. Sea ice changes, sea ice loss at both poles in the past 25 years contributes about 0.15 watts per square meter to the global increase of absorbed solar energy. Darkening is also caused by increasing greenhouse gases, mainly the water vapor feedback, right? Because water is strongly absorbing at red and near infrared wavelengths, but the water vapor feedback is on the order of 0.1 watts per square meter. So you've got the darkening from sea ice, 0.15, water 0.1. So most of the nearly 2 watts per square meter, just showed it to be 1.97 increase of solar radiation absorbed by Earth, has to be due to the aerosol and cloud changes. But how much is aerosol direct effect and how much is cloud feedback? So the aerosol forcing occurs in two ways. The direct effect is, it blocks some of the radiation coming to Earth. And the indirect effect is it alters cloud cover and cloud brightness because the aerosols act as cloud condensation nuclei. It's a mechanism for cloud formation. Global aerosols have decreased during the past 25 years with decreases from Europe and the US as countries implement procedures to clean up industrial emissions, right? A lot of the aerosols were coming out of smokestacks, especially from China, beginning in about 2005. And then, so the aerosol forcing has become weaker, right? So that means that the reduction of aerosols from ships, according to Hansen, has affected global aerosol forcing as much as 0.5 watt per square meter, right? One of the things is that the ships are plying the ocean. There's a lot fewer aerosols in the oceans, and now the ships have been a huge source of them. So if you clean up the sulfur in the shipping fuels and reduce aerosols over the ocean, it has a much larger effect than reducing them over China, where the air is much dirtier, a lot more particles to begin with. So cloud feedback in the last 25 years is in the range of 1 to 1.5 watts per square meter. So it's up to 1.5 watts per square meter. That's most of the observed 2 watt per square meter increase in absorbed solar radiation in the past 25 years. So most of it is cloud feedback. And this has a huge effect on climate sensitivity. Because if you miss this effect of the clouds in your models, which the IPCC models do, you can say that the sensitivity is a lot lower. It turns out the sensitivity has to be a lot higher, that 4.5 degrees Celsius change for a doubling of CO2, because the albedo feedbacks, the feedback from the aerosols is much, much higher. And up to recently, the aerosol components canceled out a lot of the warming that we would have had otherwise. Now, Hansen uses this feedback gain concept, where basically a single equation for the equilibrium global warming for doubled atmospheric CO2, delta T equilibrium, 1.2 Celsius times 1 minus G. If there's no feedbacks, the gain G is 0. So we'd have, for 4 watts per square meter, we'd have 1.2 Celsius global warming. In the real world, we have a powerful amplifying feedback, more water vapor as the planet warms, and a moderate amplifying feedback, decreasing surface albedo as the planet warms. So the gain is about 0.5. That would give delta T to be 2.4. Okay, but in the case of strong cloud feedbacks, the gain is 0.75. That's water vapor plus sea ice plus clouds. So then the equilibrium climate sensitivity, according to this equation, delta T equivalent is 4.8. So that's more like it, but the 4.8 is a bit high. Okay, and he explains why. So for doubled CO2, the direct CO2 forcing is 4 watts per square meter. The water vapor plus sea ice equivalent forcing is double that, 8 watts per square meter. And the cloud equivalent forcing is 4 watts per square meter. So that's 16 watts per square meter total, yields 4.8 equilibrium warming. Okay, the cloud feedback is thus providing 1/4 of the total forcing, 4 out of 16. Now you have to consider the last 25 years, greenhouse gas forcing increased 1 watt per square meter. Total human-made climate forcing is probably larger because of decreasing aerosols. Okay, so when you do all the math and the number crunching, we get closer to 4.5 for the sensitivity than 4.8. And this is the global surface temperature change. And you have, these are super El Niños. We blew past the 1.5 target. We're at 1.6. The best linear fit from 1970 to 2010 is 0.18 degrees Celsius per decade, the green line. And since 2010, it's 0.3. It's much, much higher. The, other papers have shown it being even higher than this. This is the sea surface temperature anomaly. It was 0.12 Celsius per decade from 1970 to 2010, and now from 2010 to present, it's almost double, 0.22 degrees Celsius per decade. The oceans are undergoing incredibly powerful warming. Now, the global climate models are what is almost exclusively used by the IPCC, and they can tweak the numbers and actually get a canceling out. They can get they get their 3 degrees Celsius sensitivity because they handle both the sensitivity and the aerosol contribution, direct, mostly indirect, incorrectly. There's no known case in Earth history when the greenhouse gas climate forming increased at a rate approaching the speed of present human-made change. Even during the Paleocene-Eocene thermal maximum, that event was an order of magnitude slower than the human-made change in greenhouse gases. We're in uncharted territory. This is unique in Earth's history. Global climate modeling can be consuming activity. So they had a planetary research group at NASA, just Goddard Institute for Space Studies. They had to abandon almost the planetary research and just focus on Earth and the climate model and so on. Hansen talks about his books coming out soon, Sophie's Planet. He's put out a lot of chapters for your comments. So anyway, this is one of the kickers here. Okay, this is global SO2 emissions. SO2, so aerosols, the sulfur dioxide aerosols. This is IPCC aerosol forcing. It's mostly due to SO2. Okay, now we've cleaned up the air since the 70s and reduced SO2. So the forcing is going down, and this is a forcing that is, so at the peak it was close to minus 1.5 watts per square meter, and now it's heading down, down, down because of cleaning up the air. So it's about half, in fact, of the peak. So the air is getting a lot cleaner, therefore there's much fewer aerosols for direct cooling and indirect cooling via clouds. Okay, now he talks about the history of the forcing and the best estimates from the IPCC and, the simulations and stuff. So there's lots more details in here, and I'm not going to cover them all, but the summary is seeing the forest for the trees. Climate change depends on climate sensitivity and the strength of the forcing that drives the change. Of the main sources of information, paleoclimate, modern observations, and global climate models, the first two, paleoclimate and observations, are least ambiguous. All three are consistent with climate sensitivity of 4.5 degrees Celsius plus or minus 1 degree Celsius. That's to 2 sigma, that's plus or minus to 2 sigma or 95% confidence. That excludes the IPCC's best estimate of climate sensitivity, which is 3 Celsius for doubled CO2. So the IPCC is just wrong. In the real world, climate sensitivity and aerosol forcing are independent, but they're joined at the hip in climate assessments that focus on the ability of global climate models to reproduce observed global warming. It's reasonable that climate modelers use observed global temperature change to help constrain the GCMs. The complication is that there's two major unknowns. The climate sensitivity is unknown, and the climate forcing, because of the aerosol forcing, is also, so there's only one hard constraint, the observed global warming rate, and there's two unknowns. So those can have different values to explain what's happened, but they can't explain what's happened in the last couple of years. Climate sensitivity being higher means that there's greater aerosol forcing. Okay, so independent sources of information from paleoclimate on climate sensitivity, from satellite data on cloud feedback, show that in reality, climate sensitivity is high. It's much, much higher than the mainstream science accepted number of 3.0. The IPCC has underestimated the aerosol forcing and the aerosol cooling effect. And also the aerosol cooling has weakened since 2005, mostly because of reduced emissions from China and from ships. Okay, so that's what these two papers, Global Warming in the Pipeline and Global Warming Has Accelerated, are really showing. They address these fundamental issues of climate sensitivity. Okay, so, there's the devil's in the details. So the reduction of ship aerosols has much more effect on global temperature than reduction of aerosols from China, because the ship aerosols are going into mostly pristine air. The aerosols over China are going into much dirtier air to begin with. So the effect is much greater on cloud formation from aerosols going into pristine ocean air. That just makes sense. Also, the observed global distributions of albedo or reflectivity and temperature change are consistent with a large role for ship emissions. Okay, so, and it matches the dates of when the International Maritime Organization tightened up emissions on ships. Okay, so communication of the climate situation. Even the Secretary General of the United Nations asserts that the goal of keeping global warming under 1.5 is still reachable if nations increase their emissions for future emission reductions. Right? This is nonsense. In reality, the 1.5 goal has long been deader than a doornail. So are we, the scientific community, doing an adequate job of informing governments and the public? Right? So no, I mean, when the most recent Hansen paper was put out, responses in the media by other scientists consisted of ad hominem attacks on Hansen. So they said things like, Hansen exaggerates. Hansen makes lots of mistakes. Hansen is not collegial. The analysis is too simple. Conclusions were outside the mainstream. None of the comments address the climate science in the paper, which are being summarized again in this letter. These few articles in the media by mainstream scientists, they appeared on the day that the paper came out, and they basically shut down public discussion of the paper. Okay, so what Hansen did, I guess he got pissed off. How is it that a small, all-male clique of mainstream climate scientists is able to control the climate research conversation? Because that's what's happening. The media go-to people are saying, well, yeah, don't listen to Hansen. So Hansen was annoyed. He moved back to Columbia University, where he could work with more young people and hopefully communicate more effectively to the public. And then he talks about a few other things about the International Court of Justice, the ICJ, in The Hague on global climate change. They had an important ruling. In a unanimous decision, the court determined customary international law sets forth obligations for states to ensure the protection of the climate system and other parts of the environment from anthropogenic greenhouse gas emissions. These obligations include: states have a duty to prevent significant harm to the environment by acting with due diligence, use all means at their disposal to prevent activities carried out within their jurisdiction or control from causing significant harm to the climate system and other parts of the environment. And states have a duty to cooperate with each other in good faith to prevent significant harm to the climate system. Okay, and he talks about some of the people involved, like Philippe Sands, and there's links. Dan Galpern, his long-term attorney, and Hansen were in The Hague during the trial. Hansen it was requested by the government of Mauritius that he would testify, but the government of Mauritius changed in that time, so he wasn't able to. But he thinks that some of the people attending, took his information into consideration in their judgment. And then there's some additional things in the appendix, particularly on cloud feedbacks and so on. Here's the Earth radiation balance, shortwave radiation coming down to the Earth. More and more of it is coming down to the Earth. Less and less of it is getting up to space. So the Earth is getting warmer because more shortwave is being trapped. And long wave, less long wave is getting out to space. This is the Earth energy imbalance is increasing, the difference between those two things, right? So he talks about, there's some different areas here. This is showing the long wave going out of the Earth system. And what's happening up here in this region, this is cloud area fraction. So there's the cloud area, there's much fewer clouds up at these latitudes. Since 2020, the rules on sulfur and shipping fuels were tightened in 2015, notched up greatly in 2020, and you can see there's there's a huge deficit of clouds in these regions here since 2020, and over here in these regions since even 2017 or so. But it's most noticeable here. With the reduction of shipping fuels, and most continents are in the northern hemisphere, and most commercial shipping traffic is in the northern hemisphere, these latitudes. So this makes perfect sense. The shipping fuel sulfur reductions made an enormous difference. And, it's heavily referenced, this paper. Once again, in my opinion, James Hansen hits it out of the forest. I think we're going to see more people working with James Hansen at Columbia, younger people, because he's back at the university. And, the message is just not getting out to enough people. I can't overemphasize how important this is. The climate sensitivity is 4.5 degrees Celsius per doubling of CO2. It's not 3.0. And Hansen is saying this with 99% confidence. He's basing his work on 3 different aspects: modern observations of temperature, especially in the last few years, the paleoclimate records, the difference of temperature between ice ages and warm periods, and also global climate models. Global climate models are only a third of the story, whereas the IPCC numbers, 3.0, the mainstream science is backing. They're just using global climate models, and you can change the aerosol forcing and the climate sensitivity. You can reduce the climate sensitivity and reduce the aerosol effect and model the data, and keep adjusting parameters to try to model it. But then these people threw up their hands a couple of years ago, said we can't explain this warming in the last few years. Well, their numbers are just wrong. So this is very, very important. These videos that I give you on James Hansen's work, I would say, are the single most important videos that I talk about on climate change. So please make sure you spread this information far and wide. Thank you for listening. Please consider going to my website, paulbeckwith.net, and donating to PayPal to support my research and videos. Thanks again, and bye for now.